Okay, so now I will talk about the glycolysis process. Glycolysis process is a process that we oxidize oxygen into pyruvate to produce ATP and produce ATP for energy use. Okay, so first you have the glucose here. The first thing in the process is converted into glucose 6 biphosphate, glucose biphosphate by hexokinase and glucokinase. Hexokinase can be found in the cytoplasm of all the cells, but in glucokinase you can only find it in liver and pancreatic cells. You see here pancreatic cells. See, okay, glucokinase is also to remove. It's found in the liver because it's used to remove glucose from the blood. Yeah, food from blood and then phosphate and convert to phosphate. Okay, you can see here ATP. Actually, ATP from the cell ATP contains three bonds of phosphate, and then become ATP and 2 bonds of phosphate. So it lost one phosphate group. Actually, this phosphate group goes to the fructose. You can see here. You can see in the fructose phosphate, it has only one phosphate. And then after ATP after the ATP release the phosphate group into the fructose 1,6 biphosphate. You should have 2 phosphates here, okay? It's catalyzed by this process is catalyzed by phosphofructokinase. See here, so phosphofructokinase catalyze the phosphate group from ATP. Addition of phosphate group to the fructose phosphate by the ATP, converting to ATP. Yeah, so I have 2 phosphate group here. Okay, after have 2 phosphate group convert into this aldolate and this. Okay, so this is important here. The glyceroldihyde 3-phosphate. Okay, you can see here the glyceroldihyde 3-phosphate have 1 phosphate group. Okay, so they actually have to convert later convert into later the additional phosphate will be added into this molecule. Okay, so in order for the phosphate group to attach to this molecule, you have to the hydrogen here have to be removed because there's no space for the phosphate group to attach anymore if you don't remove. Yes, here I have 1, 2, and 3, 4. You can see double bond 1, 2, 3, 4 is full already. So we have to abandon the hydrogen bond, the hydrogen bond. Okay, after abandoning the hydrogen bond, you have free electron here. Actually, the hydrogen will be form bond with the NAD and become NADH. So NAD is an electron acceptor. It accepts hydrogen and become NADH. So now the molecule has free space here as we remove the hydrogen. So the phosphate added into the molecule and becomes molecule with 2 phosphate. Yeah, by phosphoric acid. Okay. Now it has 2 phosphate group. So the ATP, which I mentioned earlier, they have 2 phosphate group. We actually bond with the phosphate group in this molecule and form ATP for energy use. Okay, so ATP for energy use. Okay, then here also ATP become ATP from the phosphate group, become pyruvate with no phosphate group. Okay, but Okay. So actually the NADH here, you see, it accepts the electron from hydrogen to create a free space for the phosphate group. So it become NADH from NAD. So as it has an extra hydrogen here, so for the process to go in the cycle, the hydrogen here in the NADH has to be abandoned, so they can form new NAD to accept the hydrogen from this molecule. Okay, so how do they abandon the the hydrogen in the NADH? So actually the hydrogen in the NADH will form bond with oxygen. So 1, 2, H2 and oxygen all become water. Okay, so it's the one of the product of the respiration. The water, so now NAD is free now. It can accept the hydrogen atom again, and then the cycle continues. But if there's lack of oxygen, if there's lack of oxygen, you cannot the NADH cannot abandon the hydrogen to oxygen, and then there's no NAD to accept hydrogen atom from this, and then no phosphate group, and then no ATP. Okay, so the NADH has to abandon. So how to abandon the hydrogen from the NADH without the helping of oxygen? So actually, you can see the product here, product. Okay, the product will actually oxidized by the the hydrogen here, hydrogen atom here, oxidized by the hydrogen atom, and become lactate. Okay, so it accepts hydrogen. So it acts as a electron acceptor, accept the hydrogen, and then become lactate. You can see here there are more hydrogen here. Okay, after the private accept the lactate, accept hydrogen and become lactate, there's now NAD. There's now NAD to use to accept the hydrogen bond from this molecule, from the glycerol 3-phosphate. So the cycle can continue. However, if there are too much lactate, it will cause damage to your muscle. Yeah. So this is the process of glycolysis. Okay, thank you for listening. Okay. Actually, how this cell abandon the hydrogen atom is catalyzed by the dehydrogenase. You see, dehydrogenase actually catalyze the abandon of the hydrogen atom. Okay, so this is all for glycolysis. Thank you very much.